Alright guys, onward to chapter 9. Still talking about arrays. And I really do think that by this point in time in your computer education and career, you probably have the idea of arrays. So I'm not going to do much more with simple storing events in there, although there, may do that. But we're going to be talking about storing references into arrays. And we'll want to hit upon the topic of two-dimensional arrays, of course. What is a two-dimensional array? It's sometimes called a matrix, right? It's a grid of numbers or values or whatever, like an Excel spreadsheet. So we talked about partially filled array. A partially filled array is an array where you've started it off, you've started filling it, but you've only got a certain number of elements in it filled and the rest of it set to its default values. Now, some people try to handle partially filled arrays. For a second. By doing something like this. If you have 10 test scores, and they're all initialized, to 0. Well, why don't I just treat the zeros? Why don't I stop processing at the first 0, right? Well, obviously that's not going to work because, student may have made a 0. 0 is a valid piece of data. So another thing that people will do is initialize the array with what is a completely invalid value, and then just use that invalid value as a marker, right? That's saying that there is no data in that element. And that's a plausible method. It kind of wastes a little bit of time going through and initializing it. Like if your test scores are 0 through 100, you could go and initialize all the values to -1. And then as you're processing it, you could say, okay, if there's a -1 in that value, in that element of the array, then it's not valid, right? So the more common technique is just to keep track of how many valid elements are there. Then right? You know that we have filled 5 of them so far, and so my list needs to go and fill 5 of them. So typically that's the easiest to do. That's kind of your default mechanism for dealing with partially filled arrays. You can kind of tuck away the idea that you might fill it within an invalid, Here's an example of that. If I had something called scores and I allocated it out to, 10 elements because I wanted to score 10 test scores in there, I could run through it, right? For int I equals 0, I is less than scores.length. Can I spell? I++, and set them all equal to some invalid marker, right? Const int not filled equals -1. So that's going to be the value that indicates that it's not filled. And then scores subscript I equals not underscore filled, right? And then later on, when you're processing it, like if you're trying to add up all the scores or whatever, int total, or I like making my total double so I don't get integer rounding when I try to calculate the average later. Double, total equals 0, and then when we rip through the scores, however method, a for each loop is easiest actually. So for int, value colon scores for every value in the scores array. Instead of just doing this, total plus equals value, we could check. We could check to see if it's equal to that not filled element yet. We could also have a counter, right? And counter how many scores. How many scores are valid. So if value not equal to not underscore filled, now we have some good data to play with, right? We could add that on to the total, we could increment our counter, and then underneath it all, here we go, right? We could then use that total, use the counter to calculate the average or whatever. If the array has no data in it, then your total will equal 0 and your counter will equal 0. And you better not try to calculate an average by dividing by 0. You'll get, an invalid response, invalid result. Anyways, that is one possible way of dealing with a partially filled array. The more common way is the way the book says, and the way that I talked about, that I showed you on the last lecture. If you have a partially filled array, then scores.length does not necessarily implement or indicate how many pieces of data you have in it, right? Because there may only be one valid piece of data in that array. You've only inserted one element into it, and it's 100 elements long. That's kind of a drag. That's why there are other data structures you might prefer to use. And specifically, there's one called array list that starts off with a length of 0, and then you can append to it. Arrays you can't append to, or it's a whole bunch of trouble if you get to the end of it and then you need to increase the size of it. Then you have to allocate a new array, copy all the old elements into it, and make sure that the new array was larger so you can start putting more data in it. So copying an array. There are easy ways of copying arrays. I believe I showed you one using the arrays helper class, right? Arrays.copyOf. But we need to go ahead and know how to do it by hand, just, satisfy the computer science part of us. So let's go ahead and make a new project. I believe this is lecture I, if the last one was H. Unfortunately, Canvas is not loading for me right now, so I can't prove that. But the last lecture was H, so nope, I see a lecture I there, so let's go with lecture J. Yeah, that's it. Okay, so we're on letter H-I-J. Make a new Ant project or Maven or whatever you want. What the difference is now, if you use Maven, you have to create your own main class. Something is really bogging the computer down. Maybe it'll work now. No? Oh, for Pete's sake. Pause the recording. Alright, let's give it another go. Lecture J. All right, copying an array. Several different ways to do it. We're going to do it by hand. How do you do it by hand? You create a new array of the same length as the old one, and then you use a for loop to copy all the elements. Well, I guess you could use a while loop, but whatever. Let's make an array and put some data in it. Int nums, int square braces nums equals curly braces 8, 6, 7, 5, close curly brace, semicolon. There we go. We're going to copy that array. Here's how not to do it. Why is that a terrible idea? We now have two references to the same array. Just like I've been talking about with objects, two references to the same thing. Not really a good idea. It's like having two street signs pointing to the same street, right? If a house burns down on that street, it doesn't matter that you have two street signs, right? It's still pointing, they're still both pointing to a street that now has a burned down house. Maybe that's a little bit too violent of an example. Anyways, if you change the data using one of these references, it will be changed for the other reference as well. I think I showed this, but anyways, if I do copy subscript 0 equals, -1, just to make it real blatant that it's been changed. And then I print out both arrays, right? System.out.println. Wouldn't it be nice if we could do this? I'm going to print out nums. Unfortunately, that doesn't work. Not like Python. Turn that on. Usually when you create an ant project, it goes ahead and sets the main project. It did not for me. Okay, this is what it prints when it runs. It just prints, you know, some kind of hashed reference to it. Doesn't do any good. So that's why we can call, you know, arrays.toString, or we can print it out with our own loop. Let's just call arrays.toString for our own. Arrays.toString, parentheses, copy. Well, let's just print the original. That'll be enough to prove it. Cannot find symbol. Add an import for java.util.arrays. Well, let's just add an import for java.util.everything. Go to the very top of your code. Remember, I do want comment blocks up at the top of your code. So, you know, when you do your homework, put your name and stuff up here. So import java.util.asterisk, all lowercase. There. Now the scanner is brought in, the arrays classes brought in, everything in that package. Right? You're going to fix that? You're going to make me add that? Okay, it's fixed. Good deal. If you click on this and it puts a red box there, that means that a breakpoint has been set there, and it's not really what we want. We need to talk about debugging. If you have not already had the experience of doing that, it's an incredibly valuable skill. All right, so system.out.println, this is the nums array. Right? And then we're just going to do the same thing and print out the copy array. Look good? Let's run it. Hammer room it. Green arrow. All right. We changed that element using the copy reference, but since nums points to the same memory space, change there as well. This is not how you copy an array. Here's how you copy an array. Really, I would use arrays.copy, but we're going to do it by hand. How about calling it good copy? Int square braces good copy equals new int. And what is the length of this array? It needs to be at the exact same length as the other one. I'm not going to go and just set it to 4, and that's cheating. Nums.length. I saw something interesting. That clone method. Nums.clone. Oh, yet again. Well, guess we'll wait on that. Array clone method. An array inherits all. Returns a duplicate copy of the same array. I like that. It's even easier than copy of. Well, we could do this then. This would be a nice way to do it. Nums.clone. I like that. That's cool. Now if we did the same trick here, if we change the first element via the copy, the original will be different, right? I mean, the original will not have been changed. So good copy, element 0, is equal to -2. And now if we print out the original again, the original nums array, it'll still say 1, right? So I just copied this. I'm going to copy them both and make them say good copy, good copy. My prediction is that the first element of the good copy array will be set to -2. The first element of the original nums array will still be set to -1. Hammer and broom, green arrow. That is actually the case. The original array was untouched. So if you need a copy of the data to play with without touching the original data, sometimes you do, right? You might want to sort the data in one instance, or you might want to play with it, make modifications to it while preserving your original array. That's a really good way of doing it. I like that way. If I was going to be doing some more professional Java programming, I would use .clone. But we got to know how to do it by hand. And by hand, I mean we're going to write our own loop. So int good, how about copy 3? This is a third copy of it. Int square brace copy 3 equals new int open square nums.length close square brace semicolon. Right now we have a new array that's the same length as the original, but it's all filled with zeros, right? Uninitialized elements. They all default to 0. Now let's write a loop. For int I equals 0, I is less than nums.length, I++, and copy 3 subscript I is equal to the original nums subscript I. Let's print out our array one more time. I'm going to copy these statements again. I'm getting a warning here. Wonder why. The array is only written to, never read from. Okay, yeah, sure, but we're going to write to it right now. Or I mean, we're going to read from it right now. Okay, so print out nums and then print out copy 3. And you know what? If I put a slash in here, backslash in, then our output would be a little bit prettier. Hammer and broom, green arrow. Okay, and we see that copy 3 is a copy of nums. Just remember how to do that. Just remember that you can step through the array to do various things. You can step through the array to calculate the sum, or perform manipulations on it, or to copy it. Looping and arrays go hand in hand. No, I've said that before. Let's say it again. Alright, notice we've got a couple more warnings here. This is going to say, you made a copy of it by hand. Manual array copy. Why don't we replace that with system.array? Okay, this is an entirely different copy command. Not using the arrays class, using the system class. What's special about this one? You get to pick the starting point. Say you only want to copy elements 2 through 10. You can put 2 there, right? And then it'll start copying them at 2 rather than 0. So hopefully our result, if we chose the correct numbers for the number of elements here and then the length there, would be an array of 8 rather than 10, or whatever, if we started it with 10. Don't know where to pull 10 out. Our current array has 4. Yes, we could try to get that to work. Int. Except I'm going to undo this because I want us to have our manual array copy there. But I'm going to make a copy of that statement so that I can refer to it. Alright, so let me undo it, get back to our manual array copy. There. So I'm going to make a new array called copy4. Int, square brace, in square brace, copy4. Semicolon. I'm not going to even allocate it because system.arrayCopy allocates it. I'm going to copy from the nums array, starting well, I guess we could do element 0 first just to prove it works. But then we're going to change it to element 1 to be skipping the first element. It's not popping up the IntelliSense with the help about what each parameter means. How about this time? You gonna work this time? No. Alright. Don't know what's going on. My computer today, no problem. System.arrayCopy. The source array. Oh, go away. The source position, the destination array, the destination position, and the length. And I lied. We do have to allocate the array to its new length. So, let's make a new int array. But since the whole goal of this was to illustrate that we could use this function to copy, fewer elements than what we really wanted to. I don't know. What am I going to do here? I'm going to make this guy 10 elements long. And we're going to copy these 4 elements, or the first 3 elements, into this array. But we're going to start this at position 5, right? So elements 2, 3, and 4 are now going to be elements 5, 6, and 7 of the new array. Okay, so copy from nums, starting at position 1, so that we skip the first element because that's 0. Copy them into array 4, starting at position 5, so it'll be elements 5, 6, and 7. And how many are we going to copy? We're going to copy 3 elements. A little bit arcane there, but let's see if it works. Oh, and I'm going to want to print them out, aren't I? Copy my print statement. All right, and as predicted, elements 1, 2, and 3 have been placed into 5, 6, and 7. So just tuck that away into your brain. You can use system.arrayCopy if you want fine-grained control over which elements you copy. It does not return a new array like the arrays class has been doing when we did .clone or when we use copy of. You have to create your new array beforehand, and then this just goes in and fills in the elements according to the parameters specified. And I don't care if you remember exactly how to do this, just tuck it away in your brain that you can, right? Copy from nums, starting at position 1, into copy 4, or into the copy 4 array, starting at position 5, and copy 3 elements. How about that? Rearranging my comments a little bit. All right. That's what that's doing. I just use copy of. I'd use .clone unless I had something else fancier I needed to do, because arrays.copy of, copy 4 equals arrays.copy of. I wish I could type arrays.copy of. You can copy a range this way as well. Right. Start at position 10 and go up to position 12, or however many. I'd have to look to see what the exact parameter definitions are, whether that's the number of elements to copy or the ending position. I believe it would be the ending position. So copy elements 4, 5, and 6 into a new array. That'd be useful. Let's do that. Let's copy just 2 elements from the nums array into one last copy array. So int square brace copy 5 equals new. No, let's call arrays dot copy of range. Why did it delete that? Copy, I want to just copy, lowercase c, copy of range. Print. What? Copy of range, parentheses, copy from nums, starting at position 0, going up to position 2. And let's print out array 5. We know the business now. Just copy and paste that line. And to continue making it easier to read, I think I'll do a backslash in there and a backslash in there. Camera broom, finish building it, run it. Okay, so we did get the first 2 elements of nums. And the array is only 2 elements long, so that's what copy range did. Copy of range, created a new array of these specified elements. What if we did 1, 2? Is it going to copy 2 elements, or is it just going to copy 1? Starting at 1 and then stopping, before it reaches 2. Just 1. So this is the starting position, and this is 1 past the end position. Don't know if you know Python, but that's just like the range statement, where if you want to count from 1 to 5, you put 1, 6 there. So starting position 1 and going up to but not including 2. You can figure out how many elements it's going to copy just by subtracting, taking the difference of those values, right? So this told it to copy 1 element. 2 minus 1 is 1. When we had a 3 here, 3 minus 1 is 2, and so our result was to copy 2 elements. All right, we know a lot about copying arrays now. The book talks about one of them. You get to pick your favorite way. I do want you to know how to do it with a for loop. And at the very least, remember .clone. Also remember that there are other copy methods inside the arrays class. And then if you're feeling, adventurous in the future and only need to copy a few elements from the array, from the middle of the array into the middle of another array, you can use system.array copy. There's probably even a method in the arrays class that's can be tuned to that finer resolution. So a histogram. A histogram is a graph that displays quantities for a set of categories. It displays quantities with bars. Short bars equate to smaller quantities. Longer bars equate, just like a graph of, year 2 we sold that much cheese or made that much cheese. Year 3 we did that. In 2004 we did that many. You know what bar graphs are. Except to print them out in Java, we would print them horizontally rather than vertically so that we could use asterisks. That'd be certainly the easiest way to print them out, unless we load up a graphics library of some kind. That wouldn't make it easier, just make it prettier. So we have a nums array with some data in it. I'm not liking the fact that there's a -1 in it at this point, because how would you print -1 in a histogram? So I'm going to change the first element of our array, or maybe just make a new one. So int square braces data equals, let's just put some data in it, right? Curly brace, 5, 1, 2, 10. Right? Some data to print out. Close curly brace, semicolon. Now we're going to display a histogram. It's a histogram. Well, on the first row, we're going to print 5 asterisks. On the second row, we're going to print 1. On the third row, we're going to print 2. And on the fourth row, we're going to print 10. For each loop is the fastest way of getting that data out. So as long as I don't need that index number, which for each loop does not give you an index number, unlike the kind of for loop that we used up there. For parentheses, int value, colon data, for every value in the data array. Now we need another little loop to print out all the asterisks. So for parentheses, int I equals 0, I is less than value, so first time value is going to equal 5, and so we're going to go from 0 to 1 less than 5 elements, semicolon I plus plus, curly brace, system.out.print, not println, because we don't want to go to the next line until we're done printing this row. So an asterisk. And now we're ready for system.out.println. System.out.println, parentheses in, parentheses, semicolon. Right, like that. That'll print out our histogram. Right? 5, 1, 2, and 10. So what in the world are those? We may need another array describing what these elements are. Right? This may be January sales, February sales, March's sales, and April's sales. So let's make another array. Int, well, no, it's going to be an array of strings. So string, subscript, month underscore data equals, curly brace, quote, Jan, end quote, for January, quote, Feb, end quote, comma, quote, Mar, end quote, comma, quote, APR, end quote, curly brace, semicolon. There we go. If we had more pieces of data, we'd need more months. 12 pieces of data, 12 months. Down here, we're going to modify our for loop. It could be annoying, delete the whole thing and have us retype it. I guess I won't do that. But what are we going to do before we start printing out the asterisks for that row? We're just going to print out the month name. Yeah, I got to delete it all. I'm sorry. Or at least comment it out. Why? Because we're going to need the index number, not just the values. We need the index number so that we can tie these two arrays together, so that we know that 5 is associated with January, and that February position is 1, and March's data is 2, and April's data is. So we have to have an index. So we can't use a for each loop. Gonna have to just use an old-fashioned loop, starting at 0. Going out to the length of one of the arrays. Hopefully the arrays are of the same length, or this is going to be busted. Data dot length subscript I plus plus, in parentheses, curly brace. First thing, print out the month name. Don't do print line. I don't want to go to the next line. So system.out.print. How about printf so that we can specify the width? Because what if we had entire month names, right? Like January, February, March, and April. They aren't all the same length, but we would want the columns to line up nicely. Let's prove that just by changing one of these to March. I'm not going to implement this the way that I want to, just to demonstrate a point, and then I'm going to come back and modify it. So print the month data array at that specific index, right? And then let's have our little for loop that's going to get all the data out. Print them as asterisks. So int value equals data subscript I. in subscript, and let's have a for loop that counts to that. I could just copy these statements up here. For parentheses, I can't use I now because I has already been used there. So I guess I'll go with J for X, for int X equals 0, semicolon. X is less than the value, semicolon, X plus plus. Underneath that, print out an asterisk. System.out.print, parentheses, quote, asterisk, in parentheses, end quote. Once we're done with the row, once we printed out all the asterisks in that row, system.out.println to go to the next line. Room, green arrow. There we go. See, I'm not real happy with the way it looks, right? Since this month name was longer than the others. So I'm going to go and modify where we print the month out. I'm going to delete that. And use printf instead. System.out.printf, parentheses, quote, what's the longest month name? I don't know. I'm going to say that it's 12 characters long. I have no idea how long December is or whatever. I'm sure it's not 12. But anyways, %12s. Our placeholder where we are reserving 12 spaces for our month name. End quote, comma, and we want the month, which was called month data. So month underscore data, subscript, I in subscript, in parentheses, semicolon. It's going to look a lot better now that each month is going to fill up 12 spaces. There. Can't say that it looks great. We'd want to lower these numbers, right? We'd want to lower the width, and we might want to put a space after it. I'm going to do that. I'm going to put a space after the %12s. All right, that's looking pretty good. Cut this 12 down to something more reasonable. In this case, 5. 5 would be perfectly reasonable, right? I'm happy enough with that, but what if you wanted these months to be justified against the left margin rather than the right? Well, if you put a minus sign after the %, it left justifies the data rather than right justifies it. You know, right justify means line it up against the right margin, which we're seeing here, right? Everything's lined up on the right rather than the left. So I put a minus there, it'll line up on the right margin. Let's go. Excuse me, it'll line up on the left margin now because of the minus sign. And there we go. Now I kind of liked them actually tucked away next to the histogram bars. So I'm going to undo that change. So what do we got here? We've got what are known as parallel arrays. Parallel arrays are when you have two arrays of the same length where the elements are thematically linked by their index number or by their subscript. That's so important, I'm going to type it down. Parallel arrays. Parallel arrays are two or more arrays of the same length. Have to be of the same length, right? Because if you had only 3 month names and you had 4, pieces of sales data or whatever those are, wouldn't work. 2 or more arrays of the same length where the elements in the arrays are thematically linked by their subscript numbers or their index numbers. What do we mean by that? Data subscript 0 is 5. Month data subscript 0 is January, so those two are linked. Data subscript 1 is that. Month data subscript 1 is February, so in February we had that many sales. Month data subscript 2 is March, right? Data subscript 2 is that value, so on March we had that many sales, and so on for April. Let's do a slightly simpler example. It's not going to be a histogram. We're just going to come up with first names and last names. So string, subscript, in subscript, F names for first names equals, and let's put some first names in here. Susan, in quote, comma, Karen, end quote, comma, Diane, end quote, in parentheses, semicolon. And now last names. String subscript L names, that's not an I, that's a no. Susan Sontag, she's a writer, comma, Karen, I don't know any writers within the last name of Karen so Kent, and Diane Duane, another writer, wrote Star Trek novels. There we go. Those look too similar. But anyways, it'll prove the point, right? The first and the last names have the same initials, just to make it easy to spot that we've done this correctly. Now let's print them out. I'm going to print them out first name plus last name. Again, we need an index-based for loop, because otherwise how are we going to link the elements of each array by their index? So for parentheses int I equals 0, subscript, semicolon, I less than f names dot length, semicolon, I plus plus, in parentheses, curly brace, system dot out dot, I'm not going to do anything fancy and print them out in certain widths, so I'm not going to use printf. Oh, why not? %printf, make each one occupy. No, it's going to look ugly. I'm just going to use print. Println parentheses f name, well, the array is called f names in the plural, so f names subscript I in subscript plus a quote space quote plus L names subscript I in subscript in parentheses semicolon. And there we get our names, right? Susan Sontag, Karen Kent, and Diane Duane. Let's add to our array. We're going to make a third element. Excuse me, a third array, third parallel array, called foods. So string, square braces, foods equals Susan likes steak, end quote. Karen likes kelp, end quote. What does Diane like? Donuts, end quote, in curly brace semicolon. And so now our print statement needs to have a third thing. I almost feel like expanding this unnecessarily. Why would you want to do that? I'm going to go ahead and do it. Fn, short for first name, equals f names subscript 0 in subscript. Ln, short for last name, equals L names subscript 0 in subscript. Oops, I forgot to put the variable type. Capital S string Fn equals F names. Capital S string Ln equals L names. And let's get the food. Capital string, why not use the whole word? Fd equals foods subscript 0. I'm just going to delete this entire print line statement, print it back out. System.out.println, parentheses, quote. And let's use printf. Printf, parentheses, quote, %s, that's a placeholder for the first name. %s, there was a space in there. Loves, space, %s. \n, end quote, comma. Fn to fill in the first placeholder, comma. Ln to fill in the last place, second place, comma. And then food to fill in the last placeholder. So, Did I need to do this? No, I could have put F name subscript 0 there, L names subscript 0 there, and foods subscript 0 there. So this is kind of an unnecessary bit, but maybe it makes it easier to read, right? Get that data out of the parallel arrays so that we can print it out. Makes our print statement shorter. And there we go. And I made a big mistake. Horrible mistake. What did I do wrong? If you look at this, why am I getting the first element out every single time? Right? Susan Sontag steak, and then this, when I is equal to 1, again it does Susan Sontag steak, and then when I is equal to 2, it does Susan Sontag steak, which is why I printed that out 3 times. We don't want that. Change those subscripts 0 to I, and we'll be good to go. Tidy them all up, don't insert extra square braces like I did. Alrighty, there we go. Susan likes steak, Karen likes kelp, Diane likes donuts. So that's a parallel array. These are parallel arrays. They're the same length, and the elements are thematically linked by their subscript, right? These are subscript 0, these are subscript 1, and these are subscript 2. All right, let's go back to our PowerPoint and get their official definition of a parallel array if they were ready to talk about it. Searching an array. Yeah, we'll come back to that. Parallel. Oh, wait, no, we're not even talking about parallel arrays in this chapter, so I guess I won't make an assignment about parallel arrays. How about that? So searching an array. What do you do when you search an array? You start at the first position and you keep stepping through it until you find the piece of data that you want. Kind of like copying the array. Again, it's going to be a for loop. And if you get to the end of the array and you haven't found it yet, then you haven't found it yet, right? So let's create another array. Or I don't know. We could just search the foods array, not that it's very long. Search the foods array for a specific element. I'm going to take a peek at the PowerPoint so that my example looks closer to theirs. Oh, they don't show us how to do it. You have the answer down here? No? Okay. Well, I mean, I know how to do it, but I wanted my example to match the PowerPoint with the names. So, the problem description. Write a helper method named blah, blah, blah. Well, I'm not going to create a helper method out of it yet. I'm just going to write a loop right here. We have a foods array. We want to look for a specific element. Here's our search string. String target. This is what we're looking for. Or to find. String find equals, and I want to find which element is equal to kelp. End quote. Semicolon. All right, now let's find it. So we're going to create a value called found at, and I'm going to set it equal to -1. And if we get to the end of the array and found at still equals -1, that means we never found it. Now we need a for loop. We're going to search the foods array. So for, and again, we can't use a for each because if you're using for each, you don't get an index number, you just get values. So for int I equals 0, I less than foods dot length, semicolon, I plus plus, and we have to check. Got to check that answer. Got to check that value. Now, we've said in the past that you cannot compare strings by using equal equal. Instead, we have to use a method. So we'll do that. If foods subscript I in food script subscript dot equals, we could use the equals ignore case on the off chance that our cases were different, right? Like I put it in a lowercase k there. Parentheses, found at, in parentheses. So if they're the same, if we have found it, then we're going to set found at equal to I, marking which subscript in the array contains our good data. We might want to break at that point too. If we break at this point, we're going to stop at the first element that matches it. It seems like a good idea to me, because what if this array is 7,000 elements long? We find it at position 2. We really don't want to search, positions 3 through, 7,000, 6,999. Don't want to do that. So let's insert a break here, just so that we can bail out, right? Get out of the for loop early. If we get to here and found at still equals -1, we didn't find it. If parentheses found at equals -1, into parentheses, system.out.printf parentheses quote %s not found in array \n end quote, comma, find in parentheses semicolon. I'm not really digging the name find. I think target would have been a better name. Alrighty, I did a dumb mistake there. Found at equals. How about we put 2 equal signs? But if we did find it, we could do something. Like, who wants to eat kelp? Let's put something yummier in there. How about cake? Spelled with a K? I don't know. Else, found at equals the index position. That contains the desired argument element. And we can use it to change it. So foods, subscript I, in subscript equals, let's put something else in here. I don't know why I can't think of a food that starts with K. I'm going to Google foods that start with K. Kidney beans. Kimchi, kudzu, more seaweed. Let's just go with kiwi fruit. So foods, not subscript I, we don't have I anymore, we're outside of that loop. Subscript found at in subscript equals kiwi fruit in parentheses semicolon. And now let's print our arrays out again. To do that, I'm just going to scroll back up and copy my last 2 print statements, or excuse me, my for loop. So print the array, arrays, scroll back up. Here's where we print the arrays. I should have put that comment here too. Print the arrays. Copy that. Come down here, paste it, but let's put a blank line in front of it. So it's system.out.println parentheses in parentheses semicolon, and then paste that. Now we get to see the result of our hard work. Kelp was not found in the array. Sure, I'm surprised. Did I do that idiot business where I put subscript 0 or something rather than... No? Alright, I'm slightly boggled. I'm going to pause the recorder so that you don't see me flounder for... Oh heck. Debugging is a useful skill. It's hard to develop sometimes, so I'm going to demonstrate what I'm going to do. I'm going to system.out.printf parentheses quote, %d, which we're going to fill it in with the index number, space %s, which is going to be the string target that we're looking for. We're looking for find. And then %s, which is going to be equal to that element that we found, \n, end quote, comma, and the arguments are going to be I, the index number, find, what we're looking for, and foods, subscript I, in subscript, in parentheses, semicolon. I just stuck this in here so that we can see the elements that we're searching. See why we didn't find one. Well, we found it right there. All right, we're going to put a print statement here. System.out.println found it at index space end quote plus I in parentheses semicolon. You never found it. What's the difference between these two? Equals ignore case, that's not going to help. Dot equals ignore case. Why do I found that here? We're looking for our string to find here. Did that change while I wasn't watching? I'm not liking the way that looks. I'm going to rewrite it entirely. If find dot equals ignore case with capital I, capital C, parentheses, foods, subscript I, and subscript in parentheses, invert the if. I'm not going to invert the if. What would happen if I chose that? Yeah, right. I don't want to do that. Undo that. Okay. Hammer and broom. Green arrow. It found it that time. What was the difference? I'd have to undo it to see what was wrong. Is it just because I changed it to ignore case? What was wrong with my code a minute ago? I'm going to find out. I'm going to undo it. I'm going to cut that, undo it. You don't need to do this. Undo it a while. Okay, that was an idiot. I really did have parentheses found at here. I was actually comparing the string to a number. Of course, it was never equal to a number. It needed to be equal to find. So I'm going to clear up my code here so it's shorter, right? There we go. Guess I better test it and make sure it works. Yep, it changed it. Alrighty, I did not mean to make that mistake. Sometimes I make intentional mistakes, so I can go back and correct them while you watch. This was not. My mistake was I was not comparing it to our search string. Why don't we call that search string? I'm going to rename that variable. I'm just going to right click on it, do refactor, rename. I mean, it's only in a couple of places, so I could have done it by hand. Refactor, rename, or choose it from up here, refactor, rename. And I'm going to call this one search underscore string, because that's our goal. That's what we're looking for. Factor. I think I'm okay with the name found at. it would be a good idea to make this a method, because you may want to search over and over and over. You may find a specific element in an array over and over and over. Well, guess what? I'm pretty sure that there is a method that would let us search an array for a specific value. In case, well, I guess I'm going to post all the code, right? As always, I'm not sure that, if you've run into a mistake and I've kept going, you may not have been able to find it, but I'm going to scroll back up to the top and then go down page by page so you can compare your code if you need to. Just pause it as necessary. That's where main starts. Second page. Third page. Fourth page. Fifth page. Fifth page, including the entirety of the search algorithm. Sixth page. And then the very end of it is our printing of the arrays again. All right, let's go write a method that will search an array for a specific value. I'm going to tack it to the bottom rather than the top since we're down here. This is the end of main. So public static void search underscore array. We're going to pass in an array of strings. I'm just going to call it AR for array, comma, and then our target. String space, I could call it search string, just like I did up there. Target's just as good a value. But it better not be void because we need to actually return the index number. So public static int search array, parentheses string square braces AR, comma, string space target in parentheses. Searches array AR or the target, returns the index position that matches, or -1 if not found. Same kind of business. Int found at equals -1. For parentheses int I equals 0, semicolon. The name of our array is AR, so keep going while I is less than AR.length. Semicolon. I++ in parentheses. If parentheses target dot equals parentheses not found at, and I see why I made that mistake last time because it kindly filled in something that it should not. We're checking to see if it equals our element in the array. So AR subscript I in subscript. In parentheses, open curly brace, found at equals I, break, close curly brace, close another curly brace, return found at, semicolon, and then our last curly brace is the end of the search array method, and the very last one is the end of our class. And if we have anything below that, that would be a mistake. Hope this bit makes sense. I hope you can read this easily. If you wanted to, you could pull the value of that element out, right? We could say string element equals AR subscript I in subscript semicolon, and then we could do if target dot equals element, right? In parentheses, in parentheses. If you think that's easier to read, feel free to do it that way. Sometimes it's to your advantage to make your code easy to read. All right, that's our search array function. Let's search F names for Karen. Karen's going to change her name. So down here, after our for loop, but before the end of the main function, we still have something called found at up here. So found at equals search underscore array. The name of our array that we're looking for is F names, because we're looking for Karen. Our search string, our target is quote Karen, end quote, in parentheses, semicolon. And again, we have to check to see if it equals -1. If it equals -1, it wasn't found. If found at equals -1, in parentheses, system.out.println Karen not found, in parentheses, end quote, in parentheses, semicolon. Else let's change that value. Else, curly brace. Don't need to print it. I mean, I guess we could do a print message, but F names subscript found at end subscript equals quote, what's Karen's new name? Kimberly, end quote, in parentheses. Not in parentheses, end quote, semicolon. And then we can say system.out.println changed the element rather than print it out. Or change the element to space, change the element to space end quote plus F names subscript found at in subscript in parentheses semicolon. One more print statement. We're going to say what found at was equal to. System.out.println parentheses quote Karen found at end quote plus found at, or Karen found at index space end quote plus found at in parentheses semicolon. And Karen was found at index 1. We've changed that element to Kimberly, and if we printed them out, then it would say Kimberly Kent loves kiwi. All right, so what did we focus on? We focused on copying arrays. We focused on parallel arrays. We focused on searching an array and changing a value that we found in it. So the homework, although we talked a lot about copying the array, didn't make a homework assignment that involves copying the array. Here's what it is. Why don't we show the results first? We're going to ask the user, we're going to calculate a bunch of interest. Interest calculated, compound interest over a certain number of years. Sure would be neat if we drew a graph like that. Yeah, but we don't. Instead, we're going to print out a table like this. So what is the starting principal? $1,000. What is the interest rate? 10%. That'd be nice. Run for how many years? 5. So the earnings array is, after the calculations, that, and that's just printed with 2 string. Right, so it's kind of messy. And since that's messy, we want to print it nice and clean. Interest earned after 0 years, 0. Interest earned after 1 year, interest earned after 2 years, and so on, right? And so after 5 years, we would have earned, $610 beyond what our initial investment was. Don't know why that's there. Okay, so the detailed specs. The formula to calculate interest annually is this. This is not compounded monthly. I may have had y'all do a monthly compounding. This is a yearly compounding. Where P is the starting principal, I is the interest rate, as a decimal, 0.10 meaning 10%. And years is a number of years, right? So if you're going to calculate it over 5 years, that'd be 5. But since we're calculating on a yearly basis, years is actually going to wind up being, first 0, then 1, then 2, then 3, then 4, and then 5. So write a program that will ask the user for the principal, the interest rate, and the number of years. The program will then calculate and display instead of saying and display, calculate the interest earned for each year, storing the results in an array, and then displaying the results. So we got to make it a little bit more complicated than that. Of course, there's going to be an array copy involved, just for funsies. But here's what our tasks are. We're going to ask for the necessary input. We're going to create an array of doubles named earned array. That's the interest earned. It'll be of length n plus 1, where n is equal to the number of years. And there's a reason for that. If we say 5 for 5 years, there's actually 6 elements. We could skip the first one, right? Because after 0 years, you haven't earned any interest, but I want to see it in there. So you actually need to make it n plus 1 so that we have room for 6 elements. That's why the specs ask for that. Use a for loop that counts from 0 to n, not less than n, less than to equal to 10. Calculating the interest earned from each year from 0 to n. For example, if the user enters 5 years, calculate the interest for years 0, 1, 2, 3, 4, and 5. That's why we're going up to less than to equal n, right? Place each value calculated into the earned array. After the for loop concludes, print the array with arrays.toString, just for a quick and dirty, validate the data. And then copy the array into a new array named data array, and then use a loop as shown in the lecture to perform the copy. Don't just use .clone or system.array copy or anything like that. Use a loop. Then print the data array with the for loop with the results looking similar to that shown below. So then we're back to our sample input output. So this is what toString produced. Notice that the calculations after 1 year, 10%, you earned 1,000.000009. Yeah, see, there's a rounding. There's a rounding issue there. Right. So when we print it out for reals, we just want to print the first 2 decimal places, like %.2l. I challenge you to make it just say 1 year rather than 1 years. Right? Always annoys me when I see something on the internet or whatever that says, after 1 year's blah blah blah. If you can't do it, that's fine. Wouldn't be anything wrong with making it look like that. I won't count on. If you feel like making this table look fancier, feel free. I think that's good enough. All right, hope that makes sense. If you get stuck anywhere, text me, ask for help, and I will see y'all next lecture.